Hey, what's up? This is Madan here, and I've come up with your. Hey, what's up? This is Madan here, and I've come up with your next video, which is probably going to be the very last video of electrochemistry, and I'll be talking about secondary cell because the previous video was based on what is primary cell, what are the common example, and how they are constructed, what were they working and all. But right now, this is going to be the last part of the electrochemistry where I'm going to talk to you about the secondary cell. So I hope you are going to get it through, and this is going to be really helpful. In case it does, do let me know with your comments and all. So let's start with that. And what we have here is the secondary cell. So I'm talking about secondary cell. So what is a secondary cell? A cell or a battery which after use can be recharged again by passing current in opposite direction. And can be used again is called secondary cell. So, like I was saying, I'm talking about secondary cell or a secondary battery. What a secondary battery is? It's a kind of battery which after use, once it gets discharged, what you have to do, you can recharge it back again by, passing the current in opposite direction, and can be used again. So, in very simple, a battery which is rechargeable is called secondary cell, and the battery or a cell which is not rechargeable is called primary cell. So, this time, what are the common example? The most common example is lead storage cell, and the second example is inverter battery. So these are very two common example I remember for secondary cell. But in order to understand how secondary cell work, we need to expand one of them. So I'm expanding lead storage cell because this is what is given in your NCERT book. So let's try to get it through. I'm trying to help you with my weird diagram here, but I have to. So it consists of, let me write it first. It consists of lead anode and lead packed with lead oxide cathode as a grid between anode and between both the empty space is filled with 38% sulfuric acid solution And finally, the battery is shell. The battery is shell. So I repeat back, basically a lead storage cell is made up of, let me draw a particular diagram for that. You know, a lead storage cell is made up of this kind of you know, box like structure. This is your anode, and it is made up of lead, and there you have a grid. There you have a grid which is of lead packed with lead oxide. So this is your cathode and this is your anode. And after that, a solution is filled here. A solution is filled here, which is 38% H2SO4 solution, and then it is shielded here. So there it is, you know, the negative terminal here, and there it is the positive terminal. So this is how a lead storage cell is made up of. Now the question is, how does the reaction take place? So I'm writing the equation part here. So this is your anode half reaction. What happened at anode? Lead react with sulfate ion and converts into lead sulfate, and lead undergo oxidation. Therefore the oxidation number is changing from 0 to +2. So what happened at the cathode half? Cathode half, you know, lead oxide react with sulfate molecule, sulfate ion, and this reaction takes place in presence of hydrogen ion. So what happened? This produces lead sulfate. This produces lead sulfate along with water. So in order to balance, what we need to do, we need to actually multiply it by, you know, this has to be multiplied by, you know, like this has to be multiplied by 4H2O. So this becomes 2H2O, right? So the 4 hydrogen here, oxygen, and the 2 oxygen plus 4, and then 2 6. So this is what the reaction take place, and the overall redox reaction, you probably do know how this is made. You have to add both the reactants to the, you know, to their side and the products to their side. So what I'm going to do right here, I'm actually there will be some electron also. So let me write this here. So what happened? Pb, you know, plus SO4 2 negative plus PbO2, let's multiply this by 2 because there is one sulfate over here, another sulfate over here. Lead you have right there, then you have lead oxide right there with 4 hydrogen ion, and they convert into lead sulfate. There is another lead sulfate here, so this is going to be like 2 PbSO4 and plus 2H2O. Another thing you can do, like this sulfate and hydrogen ion can add together, so this will become lead plus, you know, H2SO4, 2 molecule of H2SO4 because 4 H2SO4 is there, plus PbO2, react to produce 2 PbSO4 plus 2H2O. So this is the overall reaction for the lead storage cell. Let me see if coming in the frame or not. Yeah. So with that, I must repeat here because there was a little disturbance while I was making this happen. I said a secondary cell is a cell or a battery which after use can be recharged again by passing the current in opposite direction. There is something very important. You have to pass the current in opposite direction so that it can be used again, right? Now, what are the common examples for secondary cell? You have inverter battery, you have lead storage cell, you have many more other cells, but we need to study in detail what this lead storage cell is. So what lead storage cell is? A lead storage cell consists of a lead anode, a lead chamber, and inside that there is a lead packed with lead oxide as cathode, and all the spaces between them, that space is filled by 38% H2SO4 solution. So this is 38% H2SO4 solution in between that. Now after all the arrangement have been done, the battery is sealed. What happened then? This is what the chemical reaction. This is what the chemical reaction take place inside the cell. So let me focus over here. Okay, let's see what this is. At the anode, lead undergo oxidation and it reacts with sulfate, so it produces lead sulfate and 2 electrons are in. So there what you see that the oxidation number of lead is changing from 0 to +2, so therefore it is an oxidation anode, which is also called anode half reaction. On the second part, what happened? The oxidation number of lead here is +4, is here +4, but there lead is having a +2 here, a +2 here. So what happened? Lead oxide react with sulfate ion and 4 hydrogen ion, and this converts into lead sulfate and water. So what we see that the oxidation number is changing from +4 to +2. So this is a kind of reduction. Shall I write this because there is no space there? So this is a case of reduction. So on the cathode, lead undergo reduction, and on the anode, lead is undergoing oxidation. So when you add both of them, what's going to happen? Reactant of this reaction and the reactant of these reaction, they are going to be on the left side. I do know what probably you have to do. So this is what a lead storage cell work here. This is how a lead storage cell work, and it is very, very important. Why? Because this will be something you cannot even miss for your board exam, because I have what I experience with my day-to-day teaching experience is that this has been a very common question in the board exam. So what most important part of this particular topic is these reactions. These reactions is very much important. So this is what we call this is what we call discharging reaction. So what I'm going to do, these reactions takes place during discharging. Right? So you need to be very careful about this particular topic here, is that these reactions happens during the discharging of the lead storage cell. So now the question is, if there is a question in your board exam, write the reaction that takes place during charging of the reaction, right? So what you have to do, let me write it first, then I will help you with that. So when battery is charged, the reaction at anode take place at cathode. And the reaction at cathode take place at anode. One more thing, for both reaction, the reactants become product and product become reactant. So what I mean to say here, let me see things are going well. Okay, so what I'm trying to say that these reactions are taking place when the battery is discharging. So these are the discharging reaction. If there is a question write the reaction that take place during charging of lead storage cell, what you need to do, the first thing you have to do, write this reaction, as cathode. So this reaction will take place at the cathode, right? And this will take place at the anode. So the first thing you have to do, when battery is charging, the reaction at anode takes place at cathode, and the reaction at cathode takes place, at anode. And for this, another thing you have to be very careful with is that the reactants become product. For example, if you are writing the anode reaction as a cathode, so what you need, let me, write, okay. So what we have this reaction as cathode. So what I'm going to do, I'm, making these two as a reactant here, and these as a product. So anode, right? So I'm making this one as a reactant. So PbSO4 plus 2H2O, it gives PbO2 plus SO4 2 negative plus 4H2, 4H positive. And then I'm making this reaction as cathode. So what I'm going to do, I'll be writing the product first. So PbSO4 plus 2 electron, and this will convert into Pb plus SO4 2 negative. So that is what happened when you write the reaction for the charging. Another thing is that you have to add the reaction. So the overall reaction is going to be this is going to be like PbSO4, 2 PbSO4 plus 2H2O gives, there will be like, PbO2 plus you got 2H2SO4 and Pb also. So this is the overall reaction. I have tried to make, I hope I haven't missed everything here. So this is how a lead storage cell work, and this is how the reaction changes during the charging and discharging. Let me repeat back a little bit. When the battery is charging, what happened? The reaction that was taking place at anode now will take place at the cathode. What you need to do, you have to change the reactant to product and product into reactant. And then the reaction at the cathode will take place at the anode, but then you also have to change the product into reactant and reactant into product. So you just study that and let me know if this was a bit, messed up or was very, very clear. And, there's some more topic I'll do, in just a while.